Now we'll start with the numerical problems depending upon the previous section and previous hour we had. Okay, let's move on. The first question is, in the Bohr model of hydrogen atom, the electrons revolve around the nucleus in a path of radius 5.1 into 10 to the power minus 11 meter at a frequency of 6.8 into 10 to the power 5 revolutions per second. Calculate the current due to this movement, right? So it's a Bohr model of hydrogen atom. So there is only a single electron which is flowing and or rotating, we can say, and it is rotating in a path, right? And it is rotating in such way. Suppose this is your electron, right? This is the nucleus of hydrogen, and this electron is revolving in a radius where path radius is given as r is equal to 5.1 into 10 to the power minus 11 meter. Right? This is given. And the frequency of the revolution is given as 6.8 into 10 to the power 5 revolution per second. Right. Now you are asked what is current. So what is the basic equation of this? Is one of the simplest question. What is the basic equation of current? I is equal to charge by time. Now, or I can write it as Q into 1 by T. What is 1 by T? That is frequency. So Q into F. Now what is charge here? Charge is an electron which is rotating. So in place of Q I will write it as E into F. What is the charge of one electron? I hope you remember the values. It is 1.6 into 10 to the power minus 19. So I'll write it as 1.6 into 10 to the power minus 19. And what is the frequency given as? It is 6.8 into 10 to the power 5. You have to calculate the value by yourself. You will get the answer as 1.088 into 10 to the power minus 3 ampere. Right? This is one of the simplest question which can be asked. Clear? Now we'll go for a little bit tougher question. Okay. Now let's move on to the second question. You are given a discharge tube and the number of hydrogen ions drifting across a cross section per second is 1 into 10 to the power 18. That is, you are given number of ions, n is given. Right, while the number of electrons drifting in opposite direction across cross section, another cross section is 2.7 into 10 to the power 8 per second. That means you are given number of electrons. So what is this? Ions means it is indicating number of positive charges. I will tell it by detail by drawing a diagram. Now, if the supply is given is of 30 volt, what is the effective resistance? I hope the scenario is there is a tube. Right, number of hydrogen ions means H plus ions. Positive ions which are drifting is 1 into 10 to the power 18. So that is a positive charges, while the number of electrons which are drifting in the other direction is N, is electrons, right? So both the flow is causing the current, right? So what is the basic equation for resistance? Second question, R is equal to V by I. Right, this is the effective current flowing through the cross section. Right, so in place of I can write the basic equation of I as Q by T. Now the charge which is flowing usually used to write N into E, right? But here there is two type of charge flow. One is positive and the other is negative. So both has to be included. So in place of Ne, I will write number of electrons into charge of an electron plus number of protons. Why did I write it as protons? H plus ions, positive charge. Right, so you are including them as protons. Into charge of a proton is same as that of charge of an electron, just the sign difference is there. Right, divided by T. Clear? So can't I take the common term E outside? Yes, I can take. So I took E outside and Ne plus Np whole divided by T. Right, this much clear. Now just substitute the values which are given in the question. Excuse me. Then E is 1.6 into 10 to the power minus 19. What is the number of electrons given? Number of electrons is given as 2.7 into 10 to the power 18, whereas number of protons or positive hydrogen ions are given as 1 into 10 to the power 18. Substitute the value and they are flowing for 1 second. Now you will get the value as 0.592 Armstrong. I am not going to show you how the calculation is done. Now you found the values current. Substitute here. How much voltage is given now? 230 volt. So resistance will be 230 divided by 0.592 Armstrong. you will get the answer as around 3.9 into 10 to the power 2 ohm. Clear? This much is clear. Now let's move on with the next question, that is the third question. A wire of resistance 5 ohm is drawn out so that its length is increased by twice its original length. What do you mean by increased by? Suppose I am increasing the value by 2 means original value plus 2. So what happens, you are increasing the original by twice means if the original length is L, the new length will be L plus 2L. I'll show you by writing. Right. Third question. So here initially the resistance is 5 ohm. The length is whatever L and area this much. Now the new resistance is R dash. You are asked what the new resistance is if new length is increased by twice its original length. So the new length will be 3L. Now when the length increases, the area of cross section decreases, right? If you are having a plastic tube or whatever, if you stretch it, its area of cross section reduces. So once you told that the length is increased means obviously the area has been reduced. So reduced area you can find. How would you find? Whatever stretching, compressing, whatever happens, the volume is constant, right? So volume is constant for a solid. So what is the volume's equation? Area into length. So area into length is equal to new area into new length. So I can write new area is equal to AL divided by L dash. L dash is 3L, right? So AL by 3L, LL cancels. So the new area is 1/3 of the old area. This much is clear. Now you just have to find the value of new resistance, right? So R dash is equal to rho into L by A, or L dash A dash, that is equal to rho. The density doesn't, the resistivity of the material is not changed, right? Because the material is not at all changing. Rho into L becomes what? 3L, L dash new length. Area becomes 1/3, so it becomes 1/3. So you will get 3 goes up, will be rho L by A. What is rho L by A? That is the initial resistance, right? So new resistance is 9 times the initial resistance. Initial resistance is 5 ohm. So 9 into 5 will be 45 ohm. That's your answer. Clear? Now we'll move on with the, okay, just a minute. See, the question I want to repeat, something has been mentioned in the question, right? The length is increased by, right? The question is, length is increased by twice. So in English, in by means it is increasing, not double, it is twice. Suppose initially if the length is L, it is increased by means you just add the new length, right? But the question, suppose it is asked, same question, a wire of resistance 5 ohm is drawn out so that its length is increased to twice its length means what would you do? In place of by, if 2 comes, if the length is increased to twice its original length, so then same scenario, but the change is extra note, right? Suppose the length, new length will be 2, right? It has increased to twice, so new length has become 2L. So what happens regarding area? It's same, volume is constant, A dash L dash. So A dash is equal to AL by L, and A in place of L dash, right? So L dash is 2L, so the area becomes half. Right, this much is clear. If you substitute the value, same here, the same scenario, R dash is equal to rho L dash by A dash, that is rho L dash is 2L divided by A dash is A by 2, so it becomes 4 L by A, that is 4 times the resistance. 4 times the resistance, that is 4 into resistance is 5 ohm, right? So the answer will be 20 ohm. This much is clear. So you understood only by one single letter you are getting 2 types of answer. If you are having by, right, increased by means the length is increased by means plus, like this. Right, suppose you are asked if the length is increased by thrice its amount, means it becomes L plus 3L. If the question is if the length is increased to thrice its value, becomes L dash is 3L. Right, I hope you understood what I wanted to convey. Now let's move on to the fourth question. Now we will deal with the next question. Two wires of equal length, one of aluminium and the other is of copper, have same resistance. Which of the two wires is lighter? Hence explain why aluminium wires are used or preferred over overhead power supply cables. And you are given resistivity of aluminium, resistivity of copper, and then you are given density of aluminium and density of copper. This much is clear. Right, so you are asked if two scenarios, that is two wires are given and one is length, both of their length are equal and their resistances are equal. So why one is preferred over the other, that is how much is the ratio of their masses, that is a question. So and the sum of parameters are given or constants. Okay, how we are going to do it? Right, all the parameters first we will write separately, then we'll go for the problem solution. Right, what and all are being given, etc. So when you read the question, it might look as a complicated step, but it is not. Right, but it's a lengthy problem. Okay, guys. And this problem has come for both CBSE board examination, NEET not, but in CBSE board of examination this question has come. So we'll write the parameters which are given. Which question number it was? I believe it is 5 or 4. Right, now what and all parameters are given? First it has been 11, so length of A, that is length of aluminium is given, let us take it as L. The length of copper also will be L. Right, now what is resistance of A? Let us take it as R. Then resistance of copper will be also R, because both of them are values are same given in the question. Now what is resistance of A? Rho A LA by A. Right, now A, I'm going to write the A suffix A because to show it is of aluminium. Right, area cross section of aluminium wire. Similarly for copper I will write the same. This much clear? Right, now it is given that both the resistance values are same. So can't I equate these two equations? Yes. So in place of these both I can write the same values, and length is also same, so I'm writing it as L by AA. This much clear? I'm going to equate these two guys. Now what happens when I equate your L, or both sides are having same parameter as L, I will cut it off. Right, AC I am cutting it L and L because it is given in the question. So it will be rho A by AA is equal to rho C by AC. So rho A and rho C is what? Is the resistivity of aluminium and copper. Let's make it as the first equation. Now we'll move, see you are asked which is having mass higher than the other. Right, so mass and then here densities are given. So we'll start with density. Density is mass per unit volume. Right, so here density, let's make it as D. Right, if the density we are take it as taking as a D, so mass I will take it as M. Right, and volume is area into length. Right, now so can't I write mass in terms of density? Right, similarly I can write A is equal to M divided by DL. Right, let it make it as a different thing. For aluminium it will be AA, for copper it will be AC. Right, so AA will be mass of aluminium divided by density of aluminium into length of aluminium. Now length of aluminium I have taken as L. Similarly I can write for copper, that is MC divided by DC into L. This much clear? Right, now I am going to replace this parameter, that is AA here and AC here. So what will be this equation become? Let's turn over the page and write it down. It will be what? The equation was what? Rho A by AA is equal to rho A by MA divided by DA goes up and L also goes up. Similarly in case of rho C by AC, so rho C divided by MC, DC and L goes up. This much clear? Now it is given that these two parts are equal in the first equation, that is rho A by AA is equal to rho C by AC. So I will equate these two sections also, rho C by MC, DC by L. I can cut off L, right? Then I can write rho A, right, by rho C in terms of MA and MC. So MC by MA is equal to rho C by rho A into DC by DA. Right, I just rearrange the equation, guys. Right, I hope you understand why I am taking MC and MA in separate side, because that is a question you are asked, what is the ratio of copper and aluminium's mass. Right, so I brought them in one side. Clear? Now guys, rho C and rho A are given as it is in question. DC and DA is density of copper and density of aluminium. It is not relative density, right? So if I consider ratio of relative density of copper and aluminium, how it is? What is relative density? I hope you remember. Relative density is, right, relative density is what? It is the density of a material when compared with the density of water. So when I consider relative density of copper, right, relative density of copper, it will be what? Density of copper divided by density of water. Similarly, if I consider relative density of aluminium, right, relative density of aluminium, it will be density of aluminium divided by density of water. What happens if I find the ratio of these two guys? dC by dW whole divided by dA by dW, right? So what would the ratio be? You guys can do by yourself. Tell me the answer. It is dC by dW divided by dA by dW. dW goes off and there will be only dC by dA, right? That is your LHS side, dC by dA. So if you find the ratio of relative density of copper and relative density of aluminium, you get the density of copper by density of aluminium. Clear? So let's move on to the problem side, that is MC by MA, right, is equal to, let's put the values which are given in your question. MC by MA is equal to, put the value what has been given in the question, 1.72 into 10 to the power minus 8 divided by 2.63 into 10 to the power minus 8, right, and density 1.9 divided by 2.7. To get the value of 2.6, that is mass of copper is 2.6 the mass of aluminium. That is mass of copper is greater than mass of aluminium. So to build power line to supply power to trains requires lengthier wires. So if you use a material which is having mass higher, that means the wire will be also heavier, which is not feasible in a complicated or what you say commercial purposes. It is very risky. Hence we use what? Aluminium, which is having least weight when compared to copper.